in Boston, Providence, and Blue Hill. So, Boston and Providence, a lot of your snowfall was actually from the January blizzard, which we're going to talk about in a little bit. And so, but Worcester and Hartford kind of missed out. So, it was below normal snowfall. Let's see, okay. And I'm just going to, this is basically the details of the climate record. So, so you can see this is the snowfall accumulation time series graphic, and so for example, this is for Providence. You can see really when the blizzard occurred, that sharp increase right here. So this green line is what happened that this past winter, and this brown line that represents the normal. So you can see we were kind of below normal, and then that one blizzard trended it above normal snowfall, and then it kind of stayed above that trend line. So, and as I've mentioned previously, this is the first winter we got to use the new climate normal, 1991 to 2020, and previously it was 1981 to 2010. So in 10 years time, it would be 2001 to 2030. So Hartford, it was below normal snowfall. And this is the rankings. You can find the climate site that is closest to where you live. So Boston still beating Worcester by 0.4 inches. So again, not out of the question. Worcester can surpass Boston if we were to get a late season winter event. So we'll see if Boston can retain the crown. Stay number one. So Providence 43.5 inches and Hartford 31.5 inches so far this season. Like I said, this is the January 7 winter storm, and there's that heavy band just set up kind of over the 495 corridor. And if you are outside of the band, you get a lot less snowfall. And here's that trough that I was talking about, 18,000 feet above sea level. When you overlaid it with the frontogenesis, and just north and west of where the frontogenetic band set up, that's where you got your heavy snowfall, and 2 to 3 inches per hour snowfall rates were reported. And you can see the radar, that's the yellow shading, that's your 30-35 dBz reflectivity. And given how cold it was all snow. And this was the lapse rates that I was talking about. And, you can see the yellow numbers, those are the higher lapse rates that correlate with elevated instability. So all things considered, we had convective snow. Even if you didn't hear thunder snow, you would still have heavier snowfall rates. It's just like your summertime thunderstorms, where you can have a heavy downpour. And switching gear, January 21st, ocean effect snow. If you live on coastal Plymouth County into the western half of Barnstable, you would have been, this event would have been quite memorable for you, because it was very long duration event, really anywhere from 3 to 6 inches. There were even some over 6 inches reports, and you can see that radar loop just you have a persistent northeast wind. I mean, really north to northeast wind, and very cold air over relatively warm ocean waters. That's going to create a lot of instability in the atmosphere and lead to heavier snowfall rates, and then you have terrain enhancement as well. I mean, if you look at if you live near Duxbury, Marshfield, there's some topography there, so it's kind of like lake effect snow. So you kind of get heavier accumulation on the what we call like the windward side of the terrain. So if you have slopes that face where the wind is coming from, you're gonna get some locally enhanced snowfall. So you can see there's actually even kind of a very subtle convergence, as shown by the wind direction. So you have northwest wind, kind of like further west, and then northeast wind further east. So there's some kind of convergence that led to greater lift. And so there was a weak trough as well that also contributed to the lift. And so here is the sounding from Plymouth, and you can see, I mean, it's a pretty deep mixed layer up to over almost 3,000-4,000 feet. So yeah. So let's see. And then you have so what you're seeing here, there's a lot of colors. I apologize, but the purple basically is a saturated layer. So it means that that part of the atmosphere is moist enough to produce precipitation and to manufacture snowflakes. And basically, let's see. And then you notice those purple lines, those brighter purple lines. That's kind of where your omega is. So you combine the instability and you combine the moisture, you can create an environment conducive for snow. And now let's talk about the gold standard snowstorm of the season. That's the January 28-29 blizzard. And you can see here's a shot outside of our office. Just some incredible drifts across the area. And you can see some 20 to 30 inches snowfall totals across southeast Massachusetts, and actually even into Long Island and Connecticut. And here's a closer look. And our office actually in northern Massachusetts, it's it's almost kind of like the jackpot area with close to 30 inches of snow. But the highest report was actually in Stoughton, just a little bit north of here, 31 inches. Boston proper, just under 2 feet of snow. Providence, not too shabby, 19 inches. And then Worcester and Hartford kind of like was left out a little bit by the snow. And we tied a record, daily record, 23.6 inches. Providence, 18.8 inches, also passed 18.3 inches set previously. Worcester also set a new daily snowfall record. And a blizzard, the one part of a blizzard is the snow, the other part is the wind. And check out some of the maximum wind gusts, really anywhere from 40 to 60 miles per hour. So it made travel impossible because we had 2 to 4 inches per hour snowfall rate combined with snow-covered roads, drifts, and just really very strong wind. So it was a day to stay inside for sure. And with such strong wind, we have to talk about coastal flooding. So there was minor to moderate flooding during the Saturday morning high tide, and the winds, because they really increase rapidly as the event progressed. So that led to kind of more of an impact, especially in all these the cities that we that are on the screen. And this was I would say this was an overall well forecasted event, and pretty much the blizzard warnings that we issued are all verified. And although I have to say that the models did a great job depicting the event, highlighting the potential up to 7 days out, but there was always a little bit of uncertainty with regards to the storm track. And if you have followed our forecast discussion, we like to talk about the so-called benchmark. So the 70 degrees west, 40 degrees north benchmark. So basically, if a low pressure system kind of passes that area, that longitude and latitude, it tends to increase the potential for accumulating snowfall for the Boston to Providence corridor. So in this case, the models had some kind of a discrepancy, and given that we observed 20 to 30 inches snowfall with crippling effects to travel, this was kind of like a high stakes forecast. So because it wouldn't take much, so if the track was just 50 miles to the east, then it would have been busted forecast, with a sharp cut of snowfall gradient. If the track was 50 miles to the west, then you would have to talk about mixing issues, because the warm air would be wrapped into the system, changing it to sleet and maybe even rain, and the snowfall totals would be cut down significantly along the 95 corridor, and the jackpot area would be further west. So there was some uncertainty leading up to the event, and eventually they trended closer to the European model. And you can see again, you just have to nail the frontogenetic band. In this case, the heavier snowfall occurred just north and west of the frontogenetic band. And here's the forecast sounding for near New Bedford. Notice that deep saturation and below freezing temperatures. And notice here the DGZ stands for dendritic growth zone. So basically, you looked at which part of the atmosphere has the best mechanism for manufacturing snow. So that kind of coincided with the snow growth zone between -12 and -18 Celsius. So there was no problem snowing, basically. And this was the HREF, the high resolution ensemble forecast. Basically, it's an ensemble of the high resolution guidance. You can see that there was this is basically the probability of seeing blizzard conditions. And you will notice that it tries to show pretty good probability of blizzard conditions over the waters, but not so much over land. So this is actually a weakness of the ensemble. The winds were not strong enough over land, at least from an ensemble forecasting standpoint. So we have basically we have a upper level low that closes off near Cape Cod. So this is favorable for heavy snow to the northwest. And again, the frontogenesis, as the event unfolded, so heavier snow north and west of where the frontogenetic band set up. And we did have a bomb cyclone, and a bomb cyclone is defined as a rapidly intensifying low pressure system that dropped 24 millibars or hectopascal in 24 hours. So in this case, the low pressure dropped 35 millibars. So it was, more than enough for a bomb cyclone criteria. So moving on to the month of February. So we had a wintry mix event, and that was, we still had widespread snow cover on the ground at that time from the blizzard. But we had a kind of a changeover to sleet and rain, especially really the sleet accumulation really was maximized north of the Pike. So you can see on this snowfall map, it's really a total sleet as well. So 2 inches in Cambridge, 2 inches in Methuen, Pepperell, and because it coincided with the commute, so it really increased the stakes. So despite the forecast of significant weather travel impacts, there were nearly 400 accidents in Massachusetts alone. So the challenge is always, how do we incorporate the human factors into decision support services? And a lot of people drive at 60, 70 miles per hour on the interstate, even in icy conditions. So that's really something that I think just moving forward, this is a challenge that we have to continually work with the emergency managers to tackle. How do we change human behavior? And you can see here's the on the left hand side is the GFS, on the right hand side is the NAM. So you see the purple colors, that's your wintry mix. That more of a pinkish red shading, that's freezing rain. And green is just rain. So you can see kind of like the GFS is, of course, being a global model, it has a coarser resolution. The NAM has a finer resolution. So you can see here's that's the possible depiction of the changeover from snow to sleet and freezing rain. So here is a depiction of the precipitation for Boston. You can see that you had a brief onset of snow and then changes over to sleet, maybe a little bit of freezing rain before finally transitioning over to rain. And here's the moisture transport. So, the question is, it was never a question of is there enough moisture to precipitate? The big question is, in what form would the precipitation be, and what time the changeover would be. And a clue that we can look at is the 925 millibar temperatures, which is at 2,500 feet. And you can see, just very tight temperature gradient across southern New England. So pretty much here, the blue lines represent below freezing temperatures at that height, and the red lines represent above 0 Celsius or 32 Fahrenheit. So, very tough forecast for sure. And you can see that's the this is 6 a.m. on the day, so you can kind of use the surface map to map out where the freezing line is. So you can see here it has lifted into New Hampshire. And then 8 a.m. as the day progressed, that line actually collapsed towards Massachusetts. And then by 12 p.m., you can see that that line has made it all the way to the Mass Pike. And it keeps progressing southward. So, but remember, this is the surface temperature. So, if your temperature is above freezing at 2,500 feet, at 5,000 feet, you will not be getting snow at the surface. You'll be getting either freezing rain or sleet. So, again, very tough forecast. Let's see. And then we had the kind of the Valentine Day snowstorm, and this was kind of like an overperformer, if you remember this event. So we have kind of like an initial burst of snow Sunday, and then there was a second half of the storm that late Sunday into Sunday night with the fluffier snow, and then some areas saw 8 to 10 inches of snow from this event. And you can see, always look at what is happening on the upper levels. So this is the 500 millibar height and vorticity map. You can notice that vigorous upper level trough moving into southern New England from the Great Lakes. And but there was a lot of uncertainty in the strength of the Arctic short wave. We know we're going to get an Arctic injection of cold air, but we were not sure how strong it's going to be. And you can see here the colored lines are the model forecast, and you can see it's kind of like a spaghetti model, and it's kind of all over the place. And here is the high resolution ensemble forecast. So you can see, it was forecasting 4 to 6 inches across much of southeast Mass, with the exception of 6 to 10 across coastal Plymouth County into Barnstable. So you can see here, here's the surface map progression as the event unfolded. And it's just showing the relative humidity and omega. So there was, basically, moral of the story is the atmosphere was saturated. There was good omega in the snow growth zone, so that led to a pretty good snow production for a long period of time. Moving on, February 19th, snow squalls. That month just was like never-ending winter. So you can see on the right hand side, you can see the time lapse from Nick showing the whiteout conditions in Springfield as a fast-moving snow squall rode through the city. And so you can see that is the snow squall on the radar loop. And those blue polygons, those are snow squall warnings that we issued. And due to a national technical difficulty issue that is outside of our control, so we did issue snow squall warnings all the way to the coast. But if you were to live on the 495 corridor, you did not get the snow squall warnings because those warnings stayed in our system. It was not transmitted. But again, it was a national issue, so national comms outage that was eventually resolved. So, but the moral of the story is, if you are if you are like in a snow squall or close to one, you should be getting a wireless emergency alert on your phone, informing that you are within a snow squall warning. So if you are driving, it's best to pull over to the side of the road, let the snow squall pass before moving on, because the visibility can briefly drop to zero, and the roads can be snow covered just within half a minute, and there might even be flash freeze conditions. So definitely want to pay attention. And sure enough, we have a sharp upper level trough providing the forcing needed for the snow squalls to cross into southern New England. And we have this thing. This is actually from the St. Louis University meteorology website, and they have this website that shows the snow squall parameter, and you can see, don't take it verbatim, but you can see that afternoon the conditions were favorable for snow squalls across much of the Northeast. And you can see it's trying to show that the snow squall would make it all the way to coastal Mass, which was what happened. And so, this is like summer thunderstorms. We look for instability, moisture, and lift. So you can see that the green line represents dew point temperature, red line represents air temperature, and when these two lines are together, it means that the atmosphere is moist, it's saturated. And then the February 25 winter storm occurred 36 hours after record-breaking warmth. So that's really the kind of like seemed to be the moral, the story of this past winter, especially towards the latter half. we would get this surge of anomalous warmth, get like a day, maybe a day or two of temperatures in the 50s and 60s, and then 48 hours later, we're back to winter and snow. And so it's kind of like a topsy-turvy winter. And if you think about it, that when we end up getting above normal snowfall and above normal temperatures for Providence and Boston, that kind of makes sense because we never really got cold for a prolonged period of time. And and that is kind of reflected in, for those of you who like to play hockey on the ice. I mean, it's tough. I mean, to find a pond that is frozen for more than a few weeks. And I think since we are kind of running a little bit short on time here, I'm just going to kind of go through this a little bit faster. I mean, the moral of the story is you have to kind of look for the upper level trough to, see how it crosses New England, look at the strength of it, and is it negatively tilted. And this is looking at 700 millibar, a little bit lower in the atmosphere. And notice how it closes off to our north. So, and this is taking a look at the near surface reflectivity and mean sea level pressure. Taking a look at 5,000 feet above sea level. So, we have the 850 millibar low tracking to our north, but notice that strong temperature gradient, especially near the south coast. Once again, blue line representing below freezing temperature, red line representing above freezing temperature. So whenever you see, when you see such a tight gradient, that is usually a favorable area for, very good low-level forcing. You can kind of make out where the coastal front is by looking at the temperature and surface map. And here, taking a look at the progression. So notice how initially it actually went further west, and then as the surface low kind of tracked southeast of Nantucket, the colder air gets wrapped around, and then eventually it collapsed back into Bristol County and Plymouth County. And then finally, actually, this was, you may or may not remember this, but March 12th, I mean, that was basically, it's almost like, so basically we started out in the 40s and rain, and eventually much colder air came in. And if you remember, there was a period of light to moderate snow that overspread the region late afternoon into early evening. And then at the tail end of the event, and we did have a wind advisory out too as well. I mean, it was blowing pretty hard, 40, 50 mile per hour wind behind the cold front. And this was actually almost like in the aftermath of the event. So as the low pressure intensified, lifted into the Gulf of Maine, we had a localized snow band that developed in a west-northwest orientation across portions of southeast Mass and northern Rhode Island, and actually was almost parallel to the 495 corridor from Worcester to northern Massachusetts. So basically, this was kind of like it's almost like a sneaky event. We did have a special weather statement out at that time, advising people that we could have flash freeze conditions because there was rain earlier, temperatures were plummeting, and there could be snow showers during the evening hours. People going out on Saturday evening, having fun, might not be paying full attention to weather. So, and so this was the radar loop, and notice how eventually you see those streaks at the end. kind of oriented northwest to southeast. So because initially that broader snow swath, was obscuring what was happening in the lower levels of the atmosphere. And this is kind of like those low top showers. And you can really see, clearly towards the end of the radar loop. So, very localized event, but it actually led to quite a few accidents. And this was a classic terrain enhanced snowfall. So for those of you who are familiar with the topography from central Mass into northern Rhode Island, you had the Blackstone River Valley in kind of south and east of Worcester. And we are not even talking about Worcester Hills here. We are talking about the topography kind of along 146, kind of from Woonsocket to Worcester. So it's really kind of like a unique event. And unfortunately, there were quite a few, multi-vehicle crashes in northern Rhode Island. So it goes to show you, you don't need a big snow event or even a snow squall to cause issues on the road. And you can see here was on the left hand side, that's the radar loop again, really showing how thin the snow band was. And I live in Attleboro, Mass, so I remember it was the end of my shift, so I drove on 123 back home, and it was a rough drive, I can tell you that. And then I picked up just under an inch of fluffy snow at home. So I think at this point, that's the end of the presentation. And it's been kind of a long winter and almost strange winter in the sense that we had the blizzard, and then we got into this pattern of topsy-turvy roller coaster ride. We have like anomalous warmth, and then snow the next day, and then rinse and repeat. So hopefully we are done with winter. We'll see. It's still possible to snow in the high terrain, so we'll see what the rest of the month brings. So I will open up to questions. If you have any questions, feel free to drop them in the chat box. And thank you for listening, and thank you for your understanding for the initial technical difficulties. Let's see. So yeah. So I'm not seeing any questions in the chat box. So I assume that there are no questions. So if you have any feedback, any further questions, and feel free to email us. Like I said, Joe couldn't join us tonight, so feel free to email him, joseph.delicarpini@noaa.gov. You can also email me as well, rodney.chai, chai, @noaa.gov as well. So, but before we wrap up, I just want to show you. Let's see, I'm just gonna drag this over. We have about 5 minutes here, so I just want to show you. Now, if you go to weather.gov, you will know instantly that a lot of weather is going across the country. So you had blizzard warnings in North Dakota and eastern Montana. High wind warning for South Dakota, and then red flag warning across much of the southern Great Plains into Nebraska, and then you had severe thunderstorm watches, tornado warnings, flash flood warnings, pretty much from Arkansas all the way into the Dixie Valley. So this is indicative of a powerful spring storm. So you would have snow on the northwest side, and that's North Dakota. Some places getting up to 2 feet of snow, if not more. and we had severe weather on the southeast side. And then in between, you had a combination of low humidity and strong winds, and that's why you have your red flag warnings. And then you had to, for all the farmers out in Kansas and Missouri, they would be concerned about, as colder air gets wrapped around behind the departing storms, you have to worry about frost and freeze potential. So, and then tomorrow for us, actually, so we have, just want to show you here. Let's see. So we had the Storm Prediction Center put our western zones into the slight risk category, so level 2 of 5 for severe thunderstorms. So really the timing is going to be kind of between 2 to 8 p.m. tomorrow. Further east, because we're going to get a backdoor cold front, so there's going to be a sharp temperature gradient across the region tomorrow. So Boston might be in the 50s, but Hartford might get into the lower 80s. So that's now and that's why actually the SPC had the western zones highlighted in slight risk, because you're going to get the warmth and instability to add more fuel for the thunderstorms. And the main threat tomorrow would be damaging straight line winds and perhaps a small hail as well. So more of the story, monitor the weather and have a plan to seek shelter if severe weather threatens your area. And cannot emphasize enough, when thunder roars, go indoors. So that's the big weather story for the next 24 hours. So the time right now is 8 p.m. So last call for questions, comments. If not, you can always email Joe or myself. And thank you so much, as always, for your time, for spending an hour of your evening with us. And I wish you a great evening and a great rest of your week. So see you next time.